Hello and welcome back. We're going to do something I find a little bit interesting that most of you have not seen before, and they're called parametric equations. And parametric equations are used particularly in physics and other places to denote how a particle moves through space, and so they are very useful. It not only gives you the equation, but it also gives you the direction something is moving. It gives us a way to model that. So let's see how these work. Now, normally you have a function of x and something like y equals x squared. In a parametric equation, the x coordinate is given by a function and the y coordinate is given by a function in this parameter called t. And they give t between a range of values. So this is saying t is between the numbers a and b. A parametric equation or relation is the set of points x comma y given by these equations called a parametric curve. T is the value from an interval, and it usually denotes angles and times or the distance a particle has traveled. So this is the definition of a parametric equation. Your x is going to come from a function and your y is going to come from a function, and that the variable in the function is t, and t is between two values. Let's see how this works, because it kind of gets a little bit confusing. It's different. So it says graph the pair of parametric equations for t between -2 and +2. Now t has what's called a t-step, where you go down. You can go by 1s, 2s, 0.1, 0.2, or whatever. We're going to go by 1s. X is going to be the same as t. X of t is just t. So whatever t is, that's x. And then y is going to be given by the opposite of t plus 2. So let's see how this works. Our t value, I'm just going to go by 1s. -2, -1, 0, 1, 2. Again, t is between -2 and 2, so when we're doing our table of values, you want to go from -2 to +2. The steps are up to you. It didn't say how close to make the steps, but we just went by 1s. So if t is 2, then x is 2, and y would be the opposite of t plus 2. So it's going to be the opposite of -2 plus 2, which is 4. So that gives us our y coordinate. Here's our x coordinate, here's our y coordinate, and when we go to plot them, that's how we'll plot them. -2, 4 will be the point on our graph. If I put a -1 in there, x and t are the same thing, and then we take the opposite of -1 plus 2 to give us 3. That'll be our y coordinate. So the point -1, 3 will be on our graph. Put in 0, you're going to get 0, 2 for your coordinates. Put in 1, you're going to get 1, 1. Put in 2, you're going to get 2, 0. If we plot these points, it'll form a curve or a graph. So let's graph it. And it goes in a certain direction. So -2, 4 goes there, and it goes, you can see here's the direction that particle would be moving. So you can model that a particle is moving from the upper left down to the lower right. Also, because there's a start and a stop point, it is a segment. So this would be the parametric equation to model a line segment. Let's look at the next one. Write a pair of parametric equations as a single equation in x and y. So you can convert between the parametric mode, the parametric equations, and the Cartesian system. The Cartesian system is just strictly x and y. So let's see how this works. Here I have two equations. This is a parametric equation in t. The strategy for converting from parametric back to just plain old x and y is to solve for t in one of the equations. So we're going to do that. We're going to take x equals 2t plus 4, and you can use either one. I could have used the y as well, but in this case I just chose this. When I solve for t, I'm going to subtract 4 and divide by 2. So I end up with 1/2 times the quantity x minus 4 equals t. I could have also put x minus 4 all divided by 2, but I'm going to leave it like this. Then what we're going to do, our step 2, is we're going to actually take this and substitute it in the other parametric equation for t. So we're going to say t is 1/2 x minus 2 if we simplify it, and we're going to substitute that in to the other equation. So I'm going to put in, instead of having 3 times t plus 3, I'm going to substitute this whole quantity in for t. So it's going to be 3 times 1/2 x minus 2 plus 3. And that's it. Now you have an equation in x and y. So this parametric equation is the same as this Cartesian equation. Alrighty, graphing in an xy plane. we know how to graph this line, or hopefully we know how to graph this line. You start off with your y-intercept of 0, -3, and then 3/2 is your slope. So that means I'm going to go 3 units up and 2 units right from this point. You got to have one point to start with. So 0, -3 is plotted on my xy plane, and then I'm going to go up 3 and over 2. So up 3 and over 2. 1, 2, 3, and right 2. That gives me another point that's on the line, and then I just graph it. Bada boom, bada bing. That's all there is to it. That's what they're going to ask you to do on the homework, is they're going to have you convert sometimes from parametric to Cartesian system and graph those points. I think you have what you need for the homework. Now I want you to grab your graphing calculator. We're going to do something just for fun, because these graphs can get kind of funky. And we're going to graph x equals 7 sine of t minus sine of 7t, y equals 7 cosine of t minus cosine 7t, and I'm going to have t be between 0 and 2 pi. If you remember, 2 pi would take us in one complete cycle, one complete circle. So if you've got your graphing calculator there, the first thing I want you to do is go to the mode button, and I want you to select par instead of func, and I want you to make sure it's in Radian mode. So set that with your graphing calculator. The second step is going to go to the window, and if you'll notice, your window changed. Instead of saying x min and x max, we're going to have t min, t max, t step, x min, x max, y min, y max. So when I go to put my values in, the t min is going to be the 0 here. The t max is 2 pi, and when you type in 2 pi, it'll change to this decimal. Now I put pi over 4 in here for the t step, but you could easily put 0.1 in there for the t step. X min is -10, x max is 10, y min is -10, and then arrow down to put a 10 in for y max. Just make sure your window's set right. Okay, so now that we have our window set, what we need to do is put in the actual equation. If I hit the y equals button, so click on the y equals button, here's what you end up with: x1 sub t and y1 sub t. And you're going to type in 7 sine t minus sine 7t. Make sure your parentheses line up. And one thing I want to mention is that in order to get this t here, just press the x button. The x button will give you this t symbol. And 7 cosine t minus cosine 7t. So once you get that typed in, click graph button. And here's what you get: a flower. Isn't that kind of cool? So if you notice, the particle moved in this direction. It moved around there when you graphed it. And that's the beauty of the parametric equations, is you can model motion with these. If we want to put a center in the middle of our flower, let's do that. So to put a center in there, under x sub 2t and y sub 2t, put in 3 sine t and 3 cosine t. That actually gives us a circle with radius 3. So if we do that, there's our final result. All right, so this was just a brief introduction to parametric equations. I hope you kind of could grasp it. If not, I'll go over some examples in class, and I'll see you tomorrow.